Welcome back. Let's continue with our lesson, starting from the concept map. Remember, we divided it into three. We started with triangles. Now we're going to look at quadrilaterals, the properties thereof. Quadrilaterals are congruent when corresponding angles and corresponding sides are equal. And if you look at that, you'd realize that that side would be equal to that one. That's when we talk of corresponding. The shortest side in the quadrilateral is equal to the shortest side there, and the longest side will be equal to the longest side, leaving out the last side to also be equal to the last side in the other triangle. So that's what we mean when we speak of corresponding angles and corresponding sides. And that means the angles are also similar, that the angles of those sides would also be then equal because the sides are equal. That's what congruency does, and in this case, that's what we're looking at. All right, here's an example. GHJKLMN is a regular heptagon. Again, I said that gives us information, and therefore GK equals to GL. There's the structure. What that information gives us is that when they say regular, it means all the angles are equal and all the sides are equal. Name two quadrilaterals in this figure. What do you notice? I've got the quadrilateral GHJK, GHJK, and what type of quadrilateral is that? That is a trapezium. And the other one would be GLMN, is also a trapezium. All right, show that the two quadrilaterals are congruent and give reasons. Already, we've got three sides that are equal, and we are told that the fourth side is also equal. So we need to write it in divided sides so that we show which is equal to which. So in this case, we'll say GH is equals to GN. And by the way, we are dealing with, in quadrilateral, GHJK, and the other one, which is GNML. So I'm looking at those two sides. I then have HJ equals to MN, and then I have JK equals to ML, and then I have been given GK is equals to GL. And because all the sides are equal, then I can safely say GHJK is therefore congruent. All the sides are equal, is therefore congruent. Even if it's a quadrilateral, congruency still uses those three lines, and it's congruent to GNMNL. And the reason for that is all sides are equal. Okay, let's look at similarity. We dealt with congruency. Let's look at a question with similarity. And it says the ABCD and AEFG are rectangles. Information: ABCD is a third of AEFG. There we see it in the structure. That means if that is 6, if that is a third, it means 6 divided by 3, it means that would be 2. And then if this is 9, a third means 9 divided by 3, it would be 3. So that is what that rectangle would give us. Now it says they show the quadrilaterals are similar and give reasons. We're looking now at the relations thereof. Already we've been told that it's a third, but then let's work it out and see. It would be GF divided by DC, which gives us 9 divided by 3, which gives us 3. And then look at the next one. What would happen if we swap them around? For interest's sake, let's rewrite that and swap them around and see the outcome thereof. So we would use DC divided by GF, and we'll have 3 divided by 9, which gives us a third when we divide both the numerator and the denominator by 3. So it gives us a third. Let's look at the next one, BC divided by EF, and it gives us 2 divided by 6. Divide both the numerator and denominator by 2, and you'll have a third. Again, you have a third, and that would be repeated for the other two sides because this is a rectangle. What parallel sides, opposite sides are parallel and equal, and therefore with that we then know that that means these two, A, B, C, D, is therefore similar to AE, FG, based on the sides are proportional. The sides are proportional. All right, let's look at then the last part of our concept map, which is now problem solving. What do we do with problem solving? Having done the first part, which is properties of triangles and properties of quadrilaterals, we looked at congruency and similarity. Now we join the information that we have to solve a problem in a question. Here's a typical question of in that regard. It says there, in triangle ABC, BC is intersected by AD, and angle ABD is equals to 3x plus 30 degrees, and angle ADC is equals to 2x plus 60 degrees. Determine the value of x. Let's look at that. Determine the value of x, and that means we have 3x. These are the angles we are talking about. That one is ADB, and that one is ADC. So they are sitting on a straight line, so they are supplementary. So we're going to say 3x plus 30 degrees plus 2x plus 60 degrees equals to 180. And because these are supplementary angles, or you can say angles on a straight line add up to 180, and therefore we now combine different ink. We now combine like terms, and the like terms that we would have, let me go back to red, and the like terms that we have is 3x plus 2x is 5x, 30 plus 60 is 90 degrees. Sorry, why am I saying equals to? Plus 90 degrees equals to 180. And then so with angle 5x equals to 180 minus 90, 180 minus 90 degrees, and it means that 5x will be equals to 90 degrees. We then the multiplicative inverse of 5x, of 5 in this case, is a fifth, and therefore we divide by 5 on the left and divide by 5 on the right hand side as well, such that x equals to 18 degrees. Yes, 90 divided by 5 is 18 degrees. All right. Now the next question, is AD perpendicular to BC? What do we understand by that sign perpendicular? It means that when the two lines are perpendicular, they meet and make an angle of 90 degrees. So we go back to the diagram and look at that angle there. It is 3x plus 30, and we look at the value of x, now that we know that x is 18, so it will be 3 multiplied by 18 plus 30 degrees. And what is 3 multiplied by 18? Let's check. So it would be 3 multiplied by 18, and it gives us 54. So that is 54 degrees plus 30 degrees, and that gives us 84 degrees. So one side there will be 84 degrees. And because it is 84 degrees, it is not 90. Therefore, those two are not perpendicular. And so we say AD is not perpendicular. Is not perpendicular to BC. And the reason is the angle is not 90 degrees. Angle is not 90 degrees. So these are not meeting, but not meeting at right angles. What we know is perpendicular meets at 90 degrees, and so these are not meeting at 90 degrees, therefore they are not perpendicular. That's what it means. So problem solving helps us to be able to look at different questions using the information that we have. Let's stop there for now. That's all for today. Thank you for joining me. Hope to see you next time. Goodbye.